Welcome to the online training program for respiratory hazards and protection in agriculture, presented by Utah State University. This module was built from the content of two existing publications from colleagues of USU Extension Pesticide Safety Education Program, or PSEP. The first is a print publication provided by the Ag Health and Safety Alliance. This is a new colleague who was met in 2021 at the American Association of Pesticide Safety Educators, or APSE, annual conference. This resource was designed to deliver respiratory hazards and safety information to the agriculture industry. The second is a worker protection flip chart from North Carolina Agro-Medicine Institute. This product was designed to help farm managers deliver worker protection standard, or WPS, trainings. Funding for this project was provided by High Plains Intermountain Center for Agricultural Health and Safety through the Emerging Issues Grant. These courses could not have been produced without the support of the National Pesticide Safety Education Center, or NAPSEC. The goal of the center is to be the premier national provider of high-quality, research-based pesticide safety education. Links to each of the USU PSEP partners mentioned will be provided at the end. It is strongly suggested you visit each and discover other resources that have been created for you by pesticide safety educators. If you need to exit the training at any time, be sure to click the Save and Quit button at the top right of your screen. Failure to click the Save and Quit button can result in losing your progress. When you have completed this module, you should be able to understand the respiratory system, respiratory hazards in agriculture, respiratory diseases that can result from agricultural exposures, how to reduce your exposure to respiratory hazards, the most common types of respirators used in agriculture, which type of respirator to use, the importance of respirator fit testing, user seal checks, and maintenance, and why the right respirator with the right fit is important. You inhale about 20,000 liters of air every 24 hours. If you're doing hard, strenuous physical work, you can inhale as much as 10,000 liters of air within 8 hours. Your lungs work hard every day, and there are defense mechanisms in place to clean the air you breathe. But some of these may be bypassed when you work strenuously. What happens when you breathe? Air is breathed in through the nose. Small bones and cartilage cause the air to swirl. Air enters the throat, which then divides into two tubes, the esophagus and the windpipe, or trachea. The esophagus carries food and drink to the stomach. The windpipe divides into two tubes called bronchi. The bronchi each enter the lungs and divide into smaller tubes called bronchioles. These bronchioles end in tiny little air sacs called alveoli, approximately 300 million, with walls thin enough to allow gases to be absorbed and released from the bloodstream. Let's talk about particle size and why it matters. Particles in the air can be all shapes and sizes. Size matters because it relates to how deeply the particles can get into your respiratory system. When talking about particles, many health and safety specialists refer to them as dusts. Click each accordion box to follow along. General nuisance dust is made up of very large particles that typically fall to the floor and surrounding surfaces. This dust is easy to see and can often make places look dirty. However, most of these particles are not inhaled into the respiratory system. Inhalable dust is small enough to be inhaled into the nose and throat areas. Most of these particles are filtered out via the normal defense mechanisms. However, they can still cause irritation. Respirable dust particles are so small they can be inhaled deep into the lungs where they will stay or be absorbed by the body. In fact, many hazardous particles are not visible to the human eye. These particles can easily bypass defenses and end up deep in your lungs, where they can then be carried to all parts of your body. With these different sized particles in mind, it's important to observe the respiratory hazards specific to agriculture. What are your normal defense mechanisms? Nasal hairs filter out large particles. Mucus traps some of the particles found in dust, fumes, and smoke. Some vapors and mists may be dissolved in the mucus. A sneeze is a reflex action that rids your nose of irritating substances. Tiny hair-like structures sweep mucus to the back of the throat where you swallow it and any substances dissolved in it. A cough is a reflex action that rids your windpipe and bronchi of mucus and dissolved or attached substances. What are the respiratory hazards in agriculture? Dusts, molds and fungi, gases, metal fumes, chemicals, and zoonotic diseases. Dusts occur in activities such as loading or unloading and shoveling grain, grinding feed, hauling bales, or feeding animals. Dust can also occur when operating or cleaning farm equipment. Symptoms such as cough, phlegm, and shortness of breath, and allergies or asthma have been reported. These dusts have also been linked with lowered breathing capacity. Molds and fungi can manifest while cleaning out bins with moldy grain or feed, or when handling molding hay. Just because you cannot see mold or mildew does not mean it isn't there. Mold and mildew are often associated with a musty smell. It is best to always wear a respirator when handling materials that have experienced water damage. Symptoms include allergic reactions, asthma, airway or throat irritation, and nonspecific symptoms like headache and poor appetite. Rarer conditions include organic dust toxic syndrome and farmer's lung. Gases posing respiratory hazards in agriculture can result from silos, nitrogen dioxide, running motors in confined areas, carbon monoxide, animals and manure pits, ammonia, hydrogen sulfide or H2S, and methane. These can cause immediate and delayed reactions, and sometimes both. Specific types of symptoms depend on exposure to which gas. Some can even be fatal with brief exposures. Respiratory exposure to metal fumes can occur when welding to perform maintenance on agricultural equipment and storage bins, or as a hobby. The type of respiratory protection worn while welding will depend on the types of welding being performed. For most fumes produced by basic welding of iron or steel, an N95 welding particulate respirator or half-full facepiece reusable respirator with a particulate organic vapor combination cartridge should be worn. Respiratory, eye, and throat irritation, coughing, wheezing, or asthma can occur, as well as a flu-like condition known as metal fume fever in some circumstances. Long-term exposure is associated with respiratory decline, bronchitis, and even loss of smell. Chemical inhalation can occur during the preparation or application of herbicides, pesticides, and anhydrous ammonia. Disinfectants used during power washing of confined animal feeding operations, or CAFOs, can also be inhaled. It is important for workers to review the pesticide labels. Manufacturers are required to include information about proper personal protective equipment, or PPE, on the pesticide label. This includes the suggested respiratory protection. The label is the law. Even if respiratory protection is not specified on the label, the worker may use a respirator during pesticide handling tasks. Agricultural workers handling pesticides should be trained specifically on health and safety for the specific compounds that they are working on. Anhydrous ammonia is a dangerous good under federal regulations. Many workers cleaning out or performing maintenance on anhydrous tanks are at risk for ammonia exposure. Workers should be adequately trained specifically on the hazards of working with this chemical and able to recognize the signs and symptoms of early exposure. A half or full facepiece reusable respirator may be provided for escape purposes only. These respirators should be fitted with the appropriate ammonia cartridge. Symptoms vary with the type of chemical. Mild, eye and airway irritation, to severe, suffocation from swelling of the airways. Zoonotic diseases are viruses and bacteria associated with animals or their byproducts, such as droppings, fleas, or mites. Some include hantavirus, anthrax, brucellosis, and influenza, and may be spread through airborne particles. It is important to contact your medical provider if you are feeling sick after a lot of potential contact with animals, especially if the animals are also ill. Controlling and preventing the spread of the diseases can help to maintain the health of producers and keep your animals healthy. Some common procedures where PPE may be necessary would be while assisting with birthing, gathering diagnostic lab samples for your veterinarian, or disposing of the carcass of a suspected sick animal. Symptoms vary with the type of zoonotic disease. Many of the symptoms of these diseases are like that of flu in humans. For example, upper respiratory issues, fever, joint pain. Many respiratory diseases take years to develop, and the symptoms are not immediately apparent. But it's important to remember that respiratory diseases due to agricultural exposures are preventable. Farmer's lung, or farmer's hypersensitivity pneumonitis, FHP, is a non-infectious allergic disease that affects normal lung function. It results from the inhalation of mold spores from moldy hay, straw, or grain. Symptoms often begin 4 to 6 hours after exposure to mold spores and can include increased coughing, coughs that bring up mucus, fever, chills, shortness of breath, discomfort in the lungs, and a tightness and/or pain in the chest. Symptoms may become most severe from 12 to 48 hours after exposure. Repeated exposures can lead to chronic conditions and serious lung damage. Upper airway respiratory diseases are a spectrum of airway diseases associated with farming and can include rhinitis, sinusitis, and mucous membrane inflammation syndrome. Agents associated with allergic upper airway respiratory diseases include hay, grain dust, molds, storage mites, and dander. Several components of organic dusts and some disinfectants and pesticides are irritants and can cause non-allergic upper airway symptoms. Organic dust toxic syndrome is also called grain fever, toxic alveolitis, or pulmonary mycotoxicosis. ODTS is an acute inflammatory reaction in the airways and small air spaces of the lungs, which is caused by exposure to very large amounts of organic dust, for example, grain dust, barns, etc. Just because you cannot see organic dust does not mean it isn't there. It is best to develop a habit of always wearing a particulate filtering respirator when performing specific tasks rather than looking for visible dust. The onset of ODTS can occur 4 to 6 hours after exposure, and symptoms may include cough, fever, chills, fatigue, muscle pain, and loss of appetite. Usually, the person recovers quickly from ODTS, usually within 36 hours, without the need for treatment. Bronchitis can be acute or chronic and includes symptoms of cough with or without mucus, sore throat, and soreness in the chest. Bronchitis affects farm workers exposed to organic dust containing allergens and microbial matter, including alive microorganisms and viruses, endotoxins, and other factors like irritant gases such as ammonia and disinfectants. Asthma symptoms can include episodes of wheezing, chest tightness, and shortness of breath and coughing. Some of the triggering agents associated with asthma in agriculture include grain dust, bacteria and fungi, insects, pesticides, animal products, pollen, tobacco leaves, chemicals, and wood smoke. Allergens are defined as agents capable of inducing an exaggerated immune response, thereby provoking allergic reactions in sensitized subjects. In farming, the agents that have been shown to cause allergic reactions include animal dander, pollens, insect fragments, storage mites, and fungal molds. These agents can cause allergic respiratory diseases in farm workers. So, how can we reduce our exposure to respiratory hazards in an agricultural setting? These recommendations are an important step and apply to all of the respiratory diseases we've discussed. Store grain at recommended moisture content levels to reduce the growth of mold spores. Ventilate animal housing areas to decrease the accumulation of ammonia and other gases. Identify high dust hazards around the farmstead and reduce dust exposure by cleaning these areas. When cleaning a barn or stable, lightly water areas to reduce the risk for airborne dust. Examine your feeding system to identify ways to decrease the release of airborne dust. Wear a NIOSH-approved and properly fitted N95 or N100 particulate respirator or a half or full face piece reusable respirator with a P100 filter when completing work tasks, for example, cleaning, harvesting, grain handling, etc., to protect yourself from dust, bacteria, fungi, insects, and animal products. The 5 essential steps to preventing or limiting potential inhalation exposures are elimination, substitution, engineering or design, safe work practices, and personal protective equipment, or PPE. Can the hazard be eliminated? Is it possible to eliminate an exposure by not growing a specific crop on your farm, not using a certain herbicide, or eliminating specific animal productions that impact your health? Is there a different product or process that I can use to decrease the risk to my health? Can I control hazards by choosing an alternate product? For example, using a less toxic chemical rather than one with a high hazard rating. Can a process, building, or machine be altered to reduce the hazard? This can be as simple as standing in a different location when unloading grain or extending a spout on a feed chute to reduce dust exposure. Is there an alternative way to perform a task to reduce the health hazard? For example, welding outdoors offers better ventilation. PPE is the last line of defense. All other controls should be attempted, and when possible, PPE should be used in combination with the above controls. For example, use a P100 respirator in combination with good ventilation, engineering and design, when in an area where you suspect mouse droppings and there is a risk of hantavirus. Choosing the proper respirator as part of your PPE in an agriculture setting requires a number of decisions to determine the particular need of the situation. There are two main types of respirators to consider: air purifying respirators and air supplying respirators. Click each tab heading to view its content. Air purifying. Air purifying respirators work by removing gases, vapors and aerosols, droplets and solid particles, or a combination of contaminants from the air through the use of filters, cartridges, or canisters. Some examples are N95 disposable respirator, half face piece reusable respirator, full face piece reusable respirator, powered air purifying respirator or PAPR, or self-contained breathing apparatus or SCBA. Air supplying. Air supplying respirators provide clean breathing air from a source independent of the work area. Examples: supplied air breathing apparatus or SABA, supplied air respirators SARs, and a combination of SARs and SABAs. It's also important to only use certified masks and filters. These masks will display the National Institute for Occupational Safety and Health, or NIOSH, certification emblem. Look for the letters TC in the product approval code stamped on the filter. TC stands for Tested and Certified. Do not use masks without this certification or with efficiency ratings less than N95. The respirator's prefix, N, R, or P, tells you if the respirator is resistant to oil. N means the respirator is not resistant to oil. R tells you that the respirator is resistant to oil. These can be used once with an oil-based exposure. P indicates that the respirator is oil-proof and can be used multiple times with an oil-based exposure. The number following that letter tells you the efficiency at which the respirator filters those particulates, measuring 0.3 microns and larger. 95 means that the respirator removes 95% of particulates. 99 tells you that the respirator removes 99% of particulates. 100 indicates that the respirator removes 99.97% of those particulates that are 0.3 microns or larger. Click each flashcard to turn it around and reveal additional information. Click the arrows to review the next and/or previous flashcard. Let's take a look at the most common types of respirators used in agriculture and how effective they are in a variety of settings or circumstances. Surgical masks are not the same as N95 masks, nor are they respirators. These are more appropriate for limiting transmission of large aerosols or droplets, such as droplets containing influenza or coronavirus. For example, surgical masks are used by large animal veterinarians when assisting with deliveries, since it helps shield from fecal matter and other biological materials. The primary benefit of surgical masks is that they are low cost and easy to purchase. One-strap masks are not the same as N95 masks, nor are they respirators. Although readily available, we do not recommend the use of these masks since they are often mistaken for an N95 respirator and there are no known benefits. Like surgical masks, cloth face coverings are not the same as N95 masks, nor are they respirators. These are more appropriate for limiting transmission of large aerosols or droplets, such as droplets containing influenza. Cloth face coverings are low cost, easy to purchase, and easy to self-manufacture, but truly provide little or no protection when it comes to respiratory hazards. N95 masks are perfect for cleaning out grain bins, working with hay, in dusty livestock buildings, in livestock buildings where biosecurity is prioritized, shop work, grinding, cutting, power washing, and even pesticide handling if the label specifies. N95s are easy to use and easy to put on and take off. You can simply throw them away and get a new one when they get dirty or saturated. Like cloth face coverings and surgical masks, they can also reduce transmission of influenza-type viruses, which is helpful for biosecurity issues. N95s with a valve are also good for cleaning out grain bins, working with hay, in dusty livestock buildings, shop work, grinding, cutting, power washing, and pesticide handling, again if the label specifies. N95s with valves are easy to use and easy to put on and take off. You can simply throw them away and get a new one when they're dirty or saturated. Some people believe they are more comfortable due to the reduced pressure of the exhalation through the valve. Please note that the N95 with valve is not recommended for biosecurity situations since the valve allows the departure of expired particles. The use of a half-face piece reusable respirator will depend on what type of filter it is paired with. For example, there are filters and cartridges for organic dusts such as grain, feed, and hay, for pesticides, paints and paint fumes, disinfectants and cleaning chemicals, and anhydrous ammonia. If fitted properly, the half-face piece particulate filtering respirator provides a tight seal around the face. It is reusable since all parts can be washed, dried, and put back together. Agricultural workers performing a variety of tasks may appreciate this type of respirator since it is so versatile. Using a full face piece respirator will depend on what type of filter is paired with the respirator. For example, like the half face piece respirator, there are filters and cartridges for organic dusts such as grain, feed, and hay, pesticides, paints and paint fumes, disinfectants and cleaning chemicals, and anhydrous ammonia. If fitted properly, the full face piece particulate filtering respirator provides a tight seal around the face. It is reusable since all parts can be washed, dried, and put back together. Agricultural workers performing a variety of tasks may appreciate this type of respirator since it is so versatile. This type of respirator also has built-in eye protection and is great for handling agrochemicals. Workers handling pesticides may prefer using a single respirator instead of having to pair a respirator with splash-resistant goggles. A powered air purifying respirator, or PAPR, works very similarly to N95 style masks. It's great for cleaning out grain bins, working with hay, in dusty livestock buildings, shop work, grinding, cutting, power washing, and pesticide handling, if the label specifies. Although this type of respirator is costly and requires more training for use, it is the only type that can be used by workers with a beard or other types of facial hair. In addition, some workers prefer to use it in hot environments because the blower provides comfort. Note, the protection factor depends on the type of facepiece. Loose-fitting facepiece PAPRs have a lower protection factor than those that are tight-fitting. A self-contained breathing apparatus, or SCBA, is essential for working inside confined spaces, storage bins, tanks, that may be oxygen deficient, or in areas, such as manure storage, with high levels of hydrogen sulfide present. Although this type of respirator is costly and requires more training for use, it is the only type that can be used in agricultural situations where airborne hazards are immediately threatening to life. That is why it is often used in emergency rescue situations. There are two basic types of fit testing: qualitative and quantitative. A fit test should ideally be conducted before an individual purchases or wears the respirator in a hazardous environment. It is an OSHA and WPS requirement that respirators are fit tested prior to use. Click each tab to view its content. Quantitative fit test. The quantitative fit test, QNFT method, can be used for any tight-fitting respirator and involves a machine that is used to measure the amount of leakage into the facepiece. In this test, the respirator's facepiece is attached to a probe that is connected to the machine by a hose. Particles are counted outside and inside the respirator to determine if the respirator has an acceptable fit. Qualitative fit test. The qualitative fit test, QLFT method, relies on a taste test which provides a pass or fail result based on the wearer detecting a test agent. While under a special hood intended to isolate the respirator user, a series of sweet or bitter agents are aspirated into the hood. If the user does not detect the agent, a series of speaking exercises and physical movements are then performed to put the respirator fit to the test. If the user still doesn't detect the agent, the respirator passes the test. In order to safely apply pesticides, many products mandate the use of personal protective equipment, including a respirator. Before applying any pesticide, you must take the time to read the product label to learn about the required protections for that product. Remember, the label is the law, and violating or ignoring the label is punishable by authorities. The EPA, or Environmental Protection Agency, regulates the use of pesticides, and as part of those regulations, requires pesticide manufacturers to list on their label the specific type of respirators needed to safely use the product. It's important to read the label carefully, since different types of respirators may be required for different interactions. For example, mixing and loading activities may necessitate a different respirator than applying the product. Employee safety is also a critical component of the need for respirators. The Worker Protection Standard, or WPS, is a series of regulations put in place so that your employees fully understand the pesticide products being used and the possible effects of exposure to them. It also outlines employer responsibilities to keep workers safe, as well as the ways in which their behavior and compliance protects them. For facilities that have 10 or more employees, OSHA, the Occupational Safety and Health Administration, regulates the use of respirators. Medical evaluations, fit testing, and training are all elements that fall under OSHA guidelines. The WPS requires these same procedures for workers who use respirators on smaller farms. For pesticide handling or application, you'll be using one of two types of respirators, tight-fitting or loose-fitting. The tight-fitting respirators have a facepiece that forms a tight seal on the user's face and are generally made of a flexible rubber-like material. These are offered in half-face and full-face versions. In order to establish a complete seal, the user will need to be clean-shaven for any tight-fitting facepiece. Men with mustaches or beards often cannot be successfully fitted, which is why many choose to use a loose-fitting helmet style. Loose-fitting respirators often resemble a helmet or hood with a cowl or shroud that extends down to the wearer's shoulders. These are often accompanied by a powered air purifying system that helps to force clean, filtered air into the helmet. Fit testing is not required for loose-fitting systems. However, users are still subject to medical clearances and proper respirator training before they can work with them. When it comes to respirator fit testing, there are a couple things to keep in mind. You must be successfully fit tested for every respirator you use. It's entirely likely that as a handler or applicator, you might use one type for mixing and loading and a different type for application. It's also possible that different pesticides will require different levels of protection. There is no one-size-fits-all approach to a proper fit. For suitable protection, each and every respirator you use must be properly fit tested for your face. This must be done every year at a minimum. If there are physical changes or respirator product changes, your safety is at stake, and the law requires you to be fit tested again. The purpose of a fit test is to see to it that the facepiece fits snugly without leaking any air, period. Any compromise to the seal between the respirator and your face could lead to your being exposed to unfiltered or contaminated air, allowing pesticide elements to be ingested, putting you at risk of damaging health effects. The most common type of fit test is known as a qualitative fit test. This test relies on the user's sense of smell or taste while wearing the facepiece. Because of this, it's recommended that you don't eat, drink, or chew gum within 15 minutes prior to taking the sensitivity test. You will need to put your respirator mask on and do a positive and negative pressure seal check in order to confirm a good seal. While wearing the respirator, the user has a hood placed over their head to isolate the air around them. Then, with the fit test aspirator, the testing professional will spray either a bitter or sweet mist into the enclosed hood, the number of sprays on the sensitivity test. If you do not taste the substance, you will then need to do some additional exercises while wearing the hood. Regular breathing, deep breathing, followed by turning your head from side to side, then up and down. You'll be asked to do some reading or perhaps counting, say backwards from 100. Finally, you'll be asked to reach over to touch your toes. Each of these is to be continued for 1 minute. During any of these exercises, if you happen to taste the substance sprayed in, then the face piece is leaking air and the test fails. You may need to readjust the mask and straps on your face piece before trying again. It's also possible that you'll need to find a different respirator in order to get a proper fit. Once more, you'll need to have a complete fit test performed for every type, style, or unit you plan to wear. And this test will need to be administered every year, or with any significant changes to your physical appearance, product usage, or if you simply have concerns about its effectiveness. Every job you perform at the farm is critical to its success, and your health and safety are the key to accomplishing those tasks effectively and efficiently. Don't confuse a fit test with a user seal check. Once you have identified a respirator that fits you, a user seal check can be performed to make sure the respirator is positioned correctly on the face or if it needs to be adjusted. Follow these simple steps to perform your user seal check for a disposable respirator. Cover the front of the respirator with both hands, taking care not to disturb its fit. When using an unvalved respirator, exhale sharply. If the respirator bulges slightly and no air leaks are detected between the face and the respirator, a proper seal has been obtained. Then work may proceed. If you cannot achieve a proper seal, do not enter the contaminated area. When using a valved respirator, inhale sharply. The respirator should collapse slightly, indicating a proper seal has been obtained. Then work may proceed. Again, if you cannot achieve a proper seal, do not enter the contaminated area. Develop a habit of performing a seal check every time you put on your respirator and throughout the day as needed. Follow these simple steps to perform your user seal check for a reusable respirator. Put the respirator on and adjust straps to a comfortable position. Be careful not to disturb the position of the respirator during the seal check. Click each accordion box to view its content. For a positive pressure check, cover the exhaust valve. Exhale gently. Breathe out and hold for 10 seconds. If the face piece bulges slightly and no air leaks are detected between your face and the face piece, a proper seal has been obtained. For a negative pressure check, cover the inhalation valves. For particulate filters, disc style, place your thumbs onto the center portion of the filters. For cartridges, place palms of hands to cover the cartridge or open area of the filter. Place hands over cartridges. Breathe in gently. If you feel the face piece collapse slightly and pull closer to your face with no leaks between your face and the face piece, a proper seal has been obtained. If there is a leak, readjust the respirator on your face and the straps and try the user seal check again. Click and drag the characteristics of a positive or negative pressure check into their proper category. If a positive or negative seal check cannot be successfully completed, check for physical cracks or breaks in the respirator, readjust the respirator, check the valves for functionality, then put it on and repeat the seal check. Continued failure to obtain a positive or negative seal check may be due to a faulty respirator, straps that are too tight or too loose, a change in the user's weight, either gain or loss, or even facial hair. Facial hair can prevent a tight seal from occurring. If facial hair is present, shave and then try again. If it's still not possible to achieve a proper seal check, try another respirator of the same make and model number. If seal checks are still unsuccessful, a different respirator and a new fit test will be necessary. A seal check is conducted by the respirator user to determine if the respirator is sealing properly. The two types of seal check to conduct are a positive and a negative pressure check. These seal checks should be performed every time you put your respirator on. This applies to dust mask style respirators as well as reusable respirator face pieces with canisters or cartridges. For a positive pressure check, place your hands over the face piece, covering as much surface area as possible, or over the exhalation port of the reusable style. The respirator user exhales lightly while blocking the paths for air to exit. A successful check is when the user feels resistance being built up inside the facepiece without any evidence of outward leakage of air at the seal. Examples would be the feeling of air on your face along the seal, foggy glasses, or a lack of pressure being built up inside the facepiece. If the dust mask respirator has an exhalation valve, then performing a positive pressure check may be impossible, as restricting the outflow of air is unlikely. Instead, a negative pressure check should be conducted. To conduct a negative pressure user seal check, cover the filter or cartridge surfaces with your hands as much as possible and then inhale. A successful check is when the facepiece collapses slightly under the negative pressure that is created, and you should not feel air passing between your face and the facepiece. If you cannot achieve a proper seal due to air leakage, you may need to be fit tested for a different respirator model or size. A user seal check should be completed each time the respirator is donned or put on. It is only applicable when a respirator has already been successfully fit tested on the individual. Remember, the user seal check is not the same as a fit test and is never to be used as a substitute for a fit test. If you are confused by the differences between the two, feel free to review the content regarding each process until you understand. Your safety is your responsibility and your priority. Also, not every respirator can be checked using both positive or negative pressure. Refer to the manufacturer's instructions for conducting a seal check for any specific respirator. This information can be found on the box or individual respirator packaging. If your respirator can be reused, develop a good habit of cleaning all the parts after use. All you need is a little soap and water. Be sure to dry it before storing. Do not put your reusable respirator in the dishwasher. Similar to what you see on labeled and packaged foods at your grocery store, there is also a shelf life for respirators. This use-by date can be found on the storage box. If respirators are not stored properly, they may not function properly. Storing respirators in extreme temperatures leads to degraded parts, like loosened face straps or nose clips. An obvious sign of degradation is discoloration of the respirator's material. It is a good idea to store respirators in locations where the temperature can stay between 32 and 85 degrees. Like most safety equipment, the sun's UV rays may damage your respirator. It is best stored indoors. Protect the respirators from dust, contamination, and humidity. Respirators should be stored in sturdy, dust-free containers, like a plastic bag or the bag provided by the manufacturer. It is helpful to have a designated clean storage space away from chemical storage for all of your PPE to reduce risk of contamination. Keep the respirator in a location where it is not crushed by heavier equipment or items. Respirators and filters or cartridges should be stored separately. How do I know when to replace my respirator or filter? Replace a mask or filter when it is visibly dirty or damaged, or when you experience difficulty breathing through it. Replace respirator cartridges when you can smell or taste chemicals or dusts while using the respirator after 8 total hours of use, in the absence of any other instructions of indications or service life, or according to the manufacturer's recommendations. In agriculture, you may encounter hazardous particles in the air while you're working. A respirator can protect you from breathing in these particles. To select and use the appropriate respirator, identify the hazard. Understand the hazard. Select the appropriate respirator. Use NIOSH-approved respirators. Have your respirator fit tested. Perform a user seal check. Reusable respirators are cost-effective options that offer protection from hazardous gases, vapors, and particles found in many agricultural environments. Half facepiece and full facepiece respirators allow for the addition of filters, cartridges, and/or combination filter cartridges for different contaminants. Use the chart below to see how different colors represent the different hazards being prevented. Always refer to safety data sheets or supplier labels for our recommended cartridge. Respirators are a critical piece of equipment for keeping you safe as you perform agriculture work. Now that you have completed this module, you should be able to understand the respiratory system, the respiratory hazards in agriculture, respiratory diseases that can result from agricultural exposures, how to reduce your exposure to respiratory hazards, the most common types of respirators used in agriculture, which type of respirator to use, the importance of respirator fit testing, user seal checks, and maintenance, why the right respirator with the right fit is important. If you feel like you need to review any or all of these subjects, feel free to navigate to the individual sections. Congratulations on completing this module for Respiratory Hazards and Protection in Agriculture, presented by Utah State University. Your health is a top priority for your employer, and you are now prepared to take the steps necessary in order to stay safe. Do not exit this browser tab without clicking the Save and Quit button located at the top right of your screen. Failure to click the Save and Quit button can result in losing your progress.